All right, let's solve quiz number 3 problem. We are verifying the divergence theorem. So we need to do a volume integral and then 2 surface integrals. Okay, so let me do the volume integral first. I need to find divergence of V, and the function here is xy x hat. If I take the partial with respect to x, I'm going to get y, and then plus y component is 2yz, partial with respect to y, 2z, plus the last term z component, partial with respect to z, will give me 3x. Okay, and now I need to take the integral over the volume of the cube. All the integration limits are x, y, and z 0 to 1, and d tau should be dx, dy, dz. So that means divergence of v d tau over this volume will be, okay, x equals 0 to 1 dx, y equals 0 to 1 dy, z equals 0 to 1 dz of y plus 2z plus 3x. All right, I decided to take z integral first. Let's go ahead and do that. All right, this is 2z, z squared over 2, 2's cancelled, that's going to be z squared. The rest is like constants, y plus 3x z, evaluated 0 to 1. It's going to give me x 0 to 1 dx, y 0 to 1 dy of, this is 1 plus y plus 3x. Okay, 1 plus 3x plus y. Now I'm going to do the y integral, same deal. X is 0 to 1 dx, so this is going to be y squared over 2 plus 1 plus 3x y, all evaluated 0 to 1. X 0 to 1 dx, so this is 1/2, this is 1 plus 3x. All right, so 3/2 plus 3x. Let's do that integral. 3/2 x plus 3x squared over 2, evaluated at 0 and 1. So it's going to give me 3/2 plus 3/2, which is 3. That's the volume integral. Now I need 2 surface integrals, along with the 4 of them already completed, that will finish the job. So let's do the surface integrals. Now, the surface integrals parallel to xy and yz plane are done. So I need surface parallel to xz plane at y equals 0, and surface parallel to xz plane at y equals 1. Now, if it is y equals 0 at the xz plane, then it will point to the left. That means in the negative y direction. So dA will be dx, dz, negative y hat. So now I need to find v dot dA. Okay. Now, since this is y hat, I need to look at the y component, which is 2yz. So it's going to give me minus 2yz dx dz. But this is at y equals 0. So this term will go away. This is 0. Okay, so I don't have to worry about that. So let's do the other one. At y equals 1, I'll get exactly the same thing for dA with just a positive sign, dx dz y hat right here. So v dot dA will be 2yz dx dz. Now y equals 1, z varies from 0 to 1, x varies 0 to 1, and let's do the integral. Okay, v dot dA equals to x is 0 to 1 dx, z is 0 to 1 z dz, and there's a 2 in front. Okay, so if we evaluate that, this is just 1. This is z squared over 2, 0 to 1, that's 1/2. That's going to give me 1. Okay, that's 1. And I have 3/2 and 1/2 from the other two integrals. So that means the total surface integral, v dot dA, will be 3/2 plus 1/2 plus 1, which is 3. That verifies it because I also got 3 for the volume integral. All good. I hope you enjoyed the solution.